So we're shifting today to section 4.3a. No more graphing today. Don't worry, we'll come back to graphing at some point. I know it's everyone's favorite. Anyway, today we are going to be looking at some of our rules about logs. We have a product rule, quotient rule, and power rule that you probably learned about in Algebra 2. So we're going to revisit those, and we're going to look at expanding and condensing log expressions today. Okay, so just using those rules to expand and condense expressions. We'll come back to change of base tomorrow. So, quick reminder, the other day I asked you to repeat to yourself about 10 times the answer to a log is, see, he's the one I heard answer or saying it 10 times before, and he knew it, right? Okay, the answer to a log is an exponent or a power. The answer to a log is a power. And what that means is when we look at expressions that involve logs, and we know that a log of something is really giving us a power, we can refer back to our rules about powers or exponents. Okay? So these go back to Algebra 1, exponential algebra. How do we deal with exponents? So if I had x to the third times x to the second, what would I do with those exponents? I add them. This becomes x to the fifth. So in a log expression, if I am taking the log of a product, okay, I'm taking the log of m times n, I can expand that out and add the two answers together. So I can take the log of m and the log of n, figure out what those powers or exponents are, and add them together. Okay, so again, the answer to a log is a power. That's a power. This is a power. And if I am multiplying here, our shortcut is to add the powers. So we're adding those expressions. Okay. What do we do if it's division? X to the fifth divided by x cubed. We subtract it. So this becomes x to the second. So our rule, if we have division, we're taking the log of m divided by n, we can subtract those two log expressions. And then the third rule, what do we do when we have a power to a power? We multiply. This becomes x to the 12th. So again, if we have something where there's a power here, we have the log base b of m raised to the p power, we can multiply that p, that power, to our log expression, which again is just another exponent. Okay? So you kind of already know these rules. You know how to deal with exponents. Now we're just putting them in a log format. So the three things that you're going to be looking for today, and I'm going to emphasize this several times, is there multiplication? Is there division? Is there a power? Those are the three things that you can expand out. Okay? All right, so the easiest way to do this is just to try a whole bunch of examples. So the first one, what does ln mean again? Log base e, right? Called natural log. So this is log base e of 7 times x. That means we have a product here. 7 times x. We're going to expand that apart, pull it apart, and it becomes what? Multiplication becomes addition. Think of your multiplication sign, right? Turn it a little bit, it's a plus sign. So multiplication turns into addition. This would become the natural log of 7 plus the natural log of x. So notice we're taking the natural log of both parts when we pull it apart. Okay. Number 2, we have log base 4 of the quantity 5x. That means it's a product, which means we expand it into addition. So log base 4 of 5 plus log base 4 of x. Question 3, same idea. There's one extra step here. This becomes log of 10 plus log of x. But what's our base? How do we know it's 10? Yeah, if there's no base written and it's log, right? Common log, base 10. Well, what is the log of 10 if we're in base 10? It's just a 1, right? 10 to the first power gives us 10. So we would simplify this down to 1 plus the log of x, the common log of x. So if it can be simplified down, we expect you to do that. If this had been log base 10 of 9, you couldn't do anything with it. All right, question 4. Do you see multiplication, division, or a power? Division. How do we expand division? So think of a division sign, right? If you take the dots away, it becomes a subtraction sign. Okay, so division is going to be pulled apart log base 7 of 19 minus log base 7 of x. One common mistake is people don't put the little bases in there. Okay, you are expected to do that. Okay, very similar, number 5, very similar to number 4. We are going to expand this. It becomes the natural log of e cubed minus the natural log of 7, right? That division gets pulled apart as subtraction. But there's one more thing in here. Of our 3, right, we also have an exponent. There's no multiplication in this one, but there is division and there is a power. We can do two things. If this had been a log of any other base instead of a natural log, that 3 would get pulled in front. Okay? Just like our power rule says. Take your power, put it in front, and make it multiplication. But it is a natural log of e to a power. What happens with those? If we had log base 2 of 2 to the x, we get x, right? The 2's match, so it cancels each other out. We get the x. So here we have log base e of e to the 3rd, which simplifies down to a 3. So again, if it can be simplified, you are expected to do that. Now, we can't simplify the natural log of 7 because we don't know e to what power gives us a 7. That's not a nice, easy answer. All right, question 6. Do you have multiplication, division, or a power? We have a power. What do we do with powers? Move them to the front and turn it into multiplication. So this is going to become 4 times the log base 5 of 7. Okay? All right. So what would we put for number 7?
8 times the log base 5 of 6.
Come on. I guess it doesn't want to move on to here. Okay, well, we'll leave it. 8 times the log base 5 of 6. That'll work. How about question 8? How's that different?
You got both adding and both multiplication.
Okay, so we have multiplication, we have a product, right? 4 times x, and we have a power. Does the power apply to the 4 and the x, or just one or the other? It applies to both, so you have to be careful here. We can bring that power in front and turn this into 4 times the log of 4x. But when we expand that 4x, that 5 goes with it. Okay? So when we pull this apart, we're going to have 5 times the log of 4 plus 5 times the log of x. Okay? That would be completely expanded the way I have it written. If you did this, right, that's equivalent, but it's not expanded quite as far as we'd want you to go. So I do want to see it written like this one. Okay? All right, question 9. Do we have multiplication, division, or a power? Yeah, we have a power. It doesn't really look like it, but what is the power? Right. Anytime we have a root, right, it's a fraction exponent. So can we move that 1/2 out? 1/2 the natural log of x? Does that work? Okay. All right, we're going to throw a couple more that have a few more things involved. Look through this one. Do we have multiplication, division, or an exponent? We see exponents and multiplication. All right, so when we pull this apart, do you have a power that applies to both? No, each term has its own power, right? The x is getting squared, the y is getting square rooted. So let's pull it apart first where that multiplication sign is. This becomes log base b of x squared plus log base b of y square rooted. And then move your powers in front of just the log that they apply to. So the 2 is going to go in front of this first one. The 1/2 is going to go in front of the second one. Does that make sense? All right, one more. What do you see? Is there multiplication? Yes. The 36 times the y to the 4th. Is there a division? Yes. Is there a power? Yes. What do we do first? Yeah, let's pull apart the division. Separate what's on top from what's on the bottom. So this is going to become log base 6 of the 4th root of x. Then what? Minus log base 6 of 36y to the 4th. Okay? Now, I want you to watch carefully on this one because there's a few tricks that a lot of kids miss. In this second piece, the log base 6 of 36y to the 4th, there is still multiplication that needs to be pulled apart, but you are subtracting everything after the minus sign, right? So we have to keep that in mind when we pull this apart or expand it, that that subtraction sign applies to everything after. So we can write this as log base 6 of the 4th root of x minus log base 6 of 36 minus log base 6 of y to the 4th. I want to be clear. Why is that second or that last piece subtracted? Yes, we are subtracting everything here. So when we expand it out, that subtraction sign applies to all of it. Another way to look at it is in the original expression, both the 36 and the y to the 4th were on the bottom, right? We were dividing by both of those pieces. So it makes sense when we expand it that we're subtracting both of those pieces. Yes? Okay, now we have some powers to deal with, some simplifying. What would we do with this 4th root? All right, so we have 1/4 log base 6 of x. How about log base 6 of 36? We can simplify that. 6 to what power gives us 36? A 2. Log base 6 of 36 is just a plain 2. Okay? Log base 6 of y to the 4th, what can we do with that? Good, pull the 4 out. So minus 4 log base 6 of y. Okay, and that would be considered fully expanded. Okay, I'm going to pause the video. You guys are going to try 1 through 9 at your tables, talk about them, make sure you agree on them. So let's check what you have for the you tries. First one, Nick. Go ahead and give me your steps along the way too, not just a final answer, okay?
Log 100 plus log x. And then log 100 goes down to 2. And then it's just plus log x.
Okay, so 2 plus the common log of x would be our answer. All right, Nick, pick somebody.
This person.
Log 2 of 32.
Log base 2 of 32.
Yeah, that's what I meant. And then log base, or minus log base 2 of x, and then log base 2 of 32 is 5.
Good.
Minus log base 2 of x.
All right. Pick someone. Okay. Natural log of e to the 5th minus natural log of 11, and then what? Okay, everybody okay with how natural log of e to the fifth becomes a 5? Yes? All right. Go ahead and pick someone, Sierra. Okay. All right. Okay, everybody understand why the 2 is in both places? Right? It's the power for both of those things? Okay. Go ahead and pick somebody else.
2 log of x plus 1.
Okay, and I did walk around and check. Some of you were trying to pull apart the x plus 4. We only have expanding rules for multiplication, division, and powers, right? So if it's a sum or a difference in parentheses here, you can't pull it apart. You can bring powers out front, but you can't split what's in the parentheses. All right, question 8. Who's up? Okay, so we can either write it as a cube root or we could write it with what exponent? 1/3 means the same thing. At this point in the process, it doesn't matter to me how you write that. Okay, if you want to leave it a cube root, you certainly can. If you want to see it more as a power, we can do that. All right, and then what? Good. All right, who's going to be the lucky last one?
1/2 log base 5x minus log base 5 25 minus 3 log base 5y.
Okay, hang on one sec. So he pulled apart several things, right, in one step. The power, the square root piece came out as a power of 1/2 in front. And then you separated the 25 times y cubed. All right, is everybody clear why both of these are minus signs? Because you really technically are dividing by all of those pieces, right? And division expands into subtraction. Okay, so then what was your final answer?
1/2 log base 5x minus 2 minus 3 log base 5y.
Okay. Agree, disagree? Aren't those fun? Once you get the hang of it, even something that looks fairly complicated like that one is not really that many steps. Okay, the last little piece. We're going to do the reverse. We're going to condense this. Now, remember that when we expanded, we took an expression that had one log piece, right? There was only one log word, and then a whole bunch of symbols. All right, when we condense it, we're getting it back to look like that. So there's going to be just one log. How many logs in my answer? 1. Okay, so do you see addition, subtraction, or a number in front, right? That's what everything turned into. Before we were saying, where is there multiplication, division, or power? But they turned into addition, subtraction, and a number in front, a coefficient. So do we have any numbers in front? No. Do we have any addition? Yes. Addition is going to condense down into multiplication. If it helps you think about your multiplying and adding signs, right? They look similar. Multiplication condenses to addition, or addition, sorry, condenses back into multiplication. So this becomes log base 4 of 2 times 32. What is 2 times 32? 64. Is that a power of 4? Because log base 4 of 64 is really saying, what power of 4 do I need to get 64? So my final answer would just be a plain 3. Okay. I see 2 subtraction signs in the next one. Can I split apart that first one? No. It's a quantity that we're taking the log of. But this one means what? Divide. When I condense it back, it's going to be division. So I'm going to write log and then 4x minus 3 divided by x. Now I want to be really clear on how I wrote that. If you write it like this, that would be wrong. I'm not taking the log of something and then dividing that answer by x. I'm taking the log of something that is being divided by an x. Okay? Don't write it like this. This is another common mistake. Okay? Then you're saying the log of a subtraction, or subtracting 2 logs is the same as dividing 2 logs. That's not the case. Okay? So be very careful. You're taking the log of all of this as one chunk when you condense it down. All right. Next one. Do we have any numbers in front? Always look for those first because they have to go back as exponents, right? That's where they came from. So we're going to put this 1/2 back as a power. We're going to put this 4 back as a power. This is going to condense down into, we'll take it in 2 steps here. The log of x to the 1/2 power plus the log of x minus 1 to the 4th power. And then the addition is going to condense back into multiplication. So we're going to write the log of, and I don't care if you write x to the 1/2 or the square root of x, either one's fine, times x minus 1 to the 4th. Right? We're taking log of all of that. Okay, question 4. Try this one at your tables. Okay, Josh, I think you were the last one. Who are you going to pick on?
ln parentheses x plus 7 power divided by x.
Like that?
Yeah.
Okay. And our last one, I see several powers. I'm going to put those back. So the 4 is going to go back, the 2 is going to go back, the 1/2 is going to go back. This becomes log base b of x to the 4th minus log base b of 6 squared minus log base b of the square root of y. Agree, disagree? Okay. Now, condensing it. We want 1 log base b in the front, right? And then our whole expression. X to the 4th, where is that going to be? On the top. Okay. The 6 squared, which is 36, we'd put it that way. 36, where is that going to go? On the bottom, because it's subtraction, it means division. Okay. And this square root of y? Also subtracting, meaning it was also being divided out. Yes? Okay. All right, so here's your assignment. No graphing.